In this video lecture, I will explain regular expression. So what is regular expression? Regular expression is a representation of a regular language which are accepted by a finite automata. So basically it's a representation of regular language, and one thing we know that a machine or a finite automata which we construct, we will be always constructing for a regular language. So there is something called as regular language, and there are three things that you should know before we go for regular expression. So we have acceptor, generator and representator. So what is acceptor? Acceptor, it will say whether a string is in the language or not. So if any regular language is given to us, we construct a finite automata for that, and there are three types of finite automata: DFA, NFA or null NFA. Okay, so whatever finite automata we construct for a language, the first thing will be we will be seeing all the valid string of that language. So machine should be able to accept all the valid string of the language and it should reject all the invalid string. So we have to see whether a string is in the language or not. So when the string will be in the language, if the string is accepted by finite automata, okay, so there are two things: either the string will be accepted or it will be rejected. So when we say the string is accepted by the finite automata, we will say that string belongs to L, and when we say the string is rejected by a finite automata, that means it does not belong to the language. Okay, now what is generator? Given a language, and that language will be a regular language, it will generate all the string in that language. So generators are nothing but the grammar, and here for regular language the grammar is called as regular grammar, and there are two types of regular grammar: right linear grammar or left linear grammar. So this in detail I will be discussing in upcoming videos. Now what is representator? Regular expression is a representator for a regular language, and if we take any language that is accepted by finite automata, so when we say a language is accepted by finite automata, that will always be a regular language. Okay, so then if I say there is a language that is accepted by finite automata, then it can be also represented by a regular expression. So the meaning is, if for any regular language, if I can construct finite automata, I can also write a regular expression for that, and both are equivalent. If I have finite automata, I can write the regular expression. If I have regular expression, I can construct a corresponding finite automata for that. Now, what is regular expression? So regular language can be described using regular expression in the form of notations consisting of the symbols such as alphabets in sigma and the operators like plus, dot and star. So basically it's a representation. Okay, and how we will write the regular expression? We will be writing the alphabet, means the alphabets will be what? Alphabets in sigma. We know this sigma is the symbol used to represent the alphabet, and these operators we will be using. Okay, now these are the three basic operators used to obtain a regular expression. These are union, concatenation and clean closure. So the operator plus is used for union operation, the symbol star is used for clean closure operation, and the symbol dot is used for concatenation. And if the regular expression is very complex, what we can do? We can even use these braces, the opening and closing braces also conveniently to understand the regular expression. So this we will be using when the regular expression is very complex. Now let us see what is regular expression. Okay, so regular expression, we can say it can be defined as, there are three rules. We can say first rule is phi is a regular expression denoting empty language. Empty language means this. Okay, and epsilon epsilon is a regular expression indicating the language containing an empty string or string of length 0, or we can say string of length 0. And A is a regular expression which indicates the language containing only A. Okay, and then rule 2 is if, and these three are primitive regular expression. Okay, so phi is a regular expression for empty language, epsilon for string of length 0 or empty string, and A is a regular expression which indicates only language has only A. So now if I say R1 is a regular expression and R2 is a regular expression, R1 plus R2 is also a regular expression. Similarly, R1 is a regular expression and R2 is a regular expression, R1 dot R is also a regular expression. If R1 is a regular expression, R1 star is also a regular expression. Why? Because we have just now seen these three operators are allowed here in while writing the regular expression: plus, dot and star. And then rule number 3 is we can use 1 and 2 any number of time, and whatever we will get is also a regular expression. So these three rules you have to remember, and using these three rules only we are going to write the regular expression. So let's take some examples. Here this is the regular expression and this is the language. So phi is a regular expression for the empty language, epsilon is a regular expression for null string, A is a regular expression for the language A which contains only one string, A, and A star is a regular expression denoting any number of A. So that means epsilon will also come, 1A, 2A, or any number of A will come. Because if I have star, always remember null string will also be included. And A plus means it will be positive clean closure. So like in here we will be having any number of A excluding null string. So at least one A will be there. So these are some example. Now in next video we will see how to write a regular expression for any given regular language. So hope the concept is clear to you. Thank you for watching.